So now let's talk about solving the second type of log equations where we only have logs on one side. And what we got to do in that case, we have to get all the logs on one side and then use the definition of log to rewrite the equation in exponential form. So again, to solve equations that are a mix of logs and constants, collect all the logs together, then use the definition of logs to rewrite the equation in exponential form. And then use our definition. So, this is exactly what I have here. I've only got logs on one side. So my argument here is that 3x plus 1. My base here is the 5. And my power is going to be to the second. So this would be 3x plus 1. 5 times 5 is 25. I'm going to take away 1 from both sides. That would be 3x equals 24. And then we're going to divide both sides by 3. Gives me x equals 8. We have to check it. 3 times 8 is 24. Plus 1 is 25. Log base 5 of 25 is going to give us 2, so it does check. All right, let's try number 13. So subtraction, so I need to rewrite this as a quotient. So that's log base 3 of x plus 6 over x minus 2 equals 2. And now we're going to rewrite this as an exponential. My base here is 5. My argument is this x plus 6 over x minus 2. And 2 is my power. So working this out, this would be x plus 6 over x minus 2. 3 squared is 9. I'm going to need to multiply both sides by that x plus 2, my LCD. So let me just write that over here. LCD equals x minus 2. And of course our restriction is that x cannot be equal to positive 2. So I'm going to multiply both sides by the x minus 2. So that gives me x plus 6, because those folks divide out here. I'll need to distribute the 9. So that'd be 9x minus 18. Let's go ahead and take away x from both sides. So that's 8x equals minus 18 equals 6. And then I'm going to go ahead and add 18 to both sides. That will give us 24. And then I want to divide both sides by 3. So divide by 8, and that will give me 3. So let's check it. 3 plus 6 is 9. So log base 3 of 9, that's actually equal to 2. 3 minus 2 is 1. Log base 3 of 1 is 0. So 2 minus 0 equals 2. It does check. So if you plug back here, 3 plus 6 is 9. Log base 3 of 9, same as log base 3 of 3 squared. That gives me 2. 3 minus 2 is 1. Log base 3 of 1 is 0. 2 minus 0 equals 2. So it does check. Let's try number 14. So again, we've got the same situation. We're going to have logs on one side. So I'm going to have to use my product rule here to put these together. So it'd be n minus 5 times n plus 2. And I'm going to need to FOIL that. So this is log base 2. So we'll get n squared plus 2n minus 5n is negative 3n, and negative 5 times 2 is negative 10. And now we need to rewrite this in exponential form. So the n squared minus 3n minus 10 is my argument. My base here is 2. The power here is 3. All right, so 2 to the third is 8. So we have n squared minus 3n minus 10 equals 8. We'll need to take away n from both sides, so that's n squared minus 3n minus 18 equals 0. And now you look for factors of 18 that add up to negative 3. So I want to use 6 and 3 with the 6 being negative. So it'd be n plus 3 times n minus 6. Bring it up over here. I'm going to set each of those factors equal to 0 and solve. So here I'll need to take away 3 from both sides. Here I'll need to add 6 to both sides. Now, let's check the negative 3, and we can see already we're going to be in trouble right here. When I plug in, because that's log base 2 of negative 3 minus 5. That's log base 2 of negative 8, and that's a no-no. So we're going to have to reject this one. Let's try a 6. 6 minus 5 is 1. Log base 2, 1 is 0, so that's good. 6 plus 2 is 8. Log base 2 of 8 is 3. 3 equals 3. The 6 does check. So let's go ahead and just kind of review now. We're going to go to our additional exercises and review. So here we got exponential functions. I'm either going to rewrite them so they have the same base, or I'm going to go ahead and change it into solve for the exponential and change into log form. So I look at that 729, and we're going to do 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, times 3, 729. So we needed 1, 2, 3, 4, 5, 6. We need 6 threes. I'm just going to verify that real quick. 3 caret key 6 is 729. So we're going to rewrite that 729 as 3 to the 6th power. And now just set the exponents equal to each other and solve. Go to add 6 to both sides. So that's 12. Divide by 3. That gives us y equals 4. And I'm going to check my answer. 3 times 4 is 12. 12 minus 6 is 6. 3 to 6 is 729. So just check. All right, let's take a look at number 2. So here, well, 32 and 4, they're both powers of 2, so I can write this 4 as 2 squared. Raising a power by a power, I multiply the exponents. If I multiply the exponents, I'm going to have to take this 2 and distribute it to both terms. If I look at 32, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 1 more 2 is 32. So I'm going to need 5 factors of 2. And so now I'm going to set the exponents equal to each other and solve. 5 equals 2x plus 6. I'm going to subtract 6 from both sides. So that's going to be a negative 1. And then divide both sides by 2. That's x equals a negative 1/2. Okay, so that one I'm going to probably use a calculator to check. That's a little bit harder. So if I take 4 caret key, negative 1/2 plus 3, hit enter. Notice that does give me 32, so this one does check. Let's try this one. So now I'm not able to write 96 as a nice power of 2. So now, before we hop into it, let's read the directions carefully. Write the solution set with exact values in terms of natural logs. Okay, so notice here, when we use the change of base, we got to use natural logs here because that's what they're telling us to do the directions. And they also give the approximate position to 4 decimal places if necessary. All right, so we got 2 things going on here. So the first thing we're going to do is we're going to use use our definition of logs to write this in log form. So my power is 2. This is log. My base here is 9, and our argument's 96. So t equals, now I have to be careful here. Normally when I'm writing the common logs, they told me I've got to write in terms of natural logs. Alright, so natural log of 96 over natural log of 9. Okay, so this is what the book calls the exact value. So now we have that box checked off. And now let's get the approximation. So I'm going to do my fraction key, ln of 96 over ln of 9. So that would give us well, if we round to 4 decimal points, 2.0773. So this would be our approximation. So number 4, we need to do the same thing. Going to rewrite this in log form. And then make Alex happy when we do the change of base. We're going to write this in terms of ln. ln 77. Remember, the 77 is higher than the 4, so the 77 has to go on top. The base 4 has to go on the bottom. Alright. Now we made Alex happy there by giving the exact form. Let's grab the approximation. Oops. Oh, I didn't mean to do that. Let's try that again. Meant to delete key. That's okay. So it's 3.1334. We're going to round that. So V would approximate 3.1334. For number 5, all right, we've got to get the 14x to both sides. So I'm going to subtract 6 from both sides. So that'd be 1651 equals 14x. Now use your change of base. X equals log base 14 of 1651, which by the change of base gives us ln, because that's what they want, Alex wants, 1651 over ln of 14. All right, so that makes Alex. Again, Alex will probably have you type those without the parentheses there. And then let's get our approximation. We're going to do the ln of 1651 over ln of 14. So that'd be 2.8075. We round that off.